Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Triangulation is brought to you by Cachefly at CACHEFLY.com.
This is Triangulation, episode 196 for April 13th, 2015. Bootstrap World. Triangulation is brought to you by SmartThings. SmartThings lets you monitor, control, and automate your home from wherever you are using your smartphone. Right now, SmartThings is offering Triangulation listeners 10% off any home security or solution kit and get free shipping in the U.S. when you go to smartthings.com/twit and use the offer code TWIT at checkout. And by Personal Capital. With Personal Capital, you get award-winning financial tools, unbiased advice, and a transparent view of all your investments. Best of all, it's free. To sign up, go to personalcapital.com/triangulation. And by Trunk Club. Have the wardrobe you've always dreamed of, handpicked by your own personal stylist. Go to trunkclub.com/twit and join Trunk Club today for free. It's time for Triangulation, the show where we get together with some of the most interesting people in technology and talk about stuff. And I am really glad to get our guest on today because this is a topic near and dear to my heart. It basically comes down to technology education in middle school, high school, and later in life. Emmanuel Schanzer is with us. He is are you a teacher by trade? What is your background, Emmanuel?
So, you know, I was a computer science major in college and minored in education. And I had this plan that I'd be a millionaire after working in the private sector, and then I'd go teach. But, you know, I worked in the private sector for a couple of years. I actually got my start over at Microsoft. And then I realized that, you know, $1 million or not, I really missed teaching and wanted to be in the classroom. So I was a math teacher and then academic coach in public middle and high schools in Boston for about 6 years.
And you've created something called Bootstrap World, or actually it's Bootstrap at bootstrapworld.org. And this is a curriculum for middle school and high school students in coding.
Yep. Yeah, so students learn computer programming as a vehicle specifically for learning algebraic and geometric concepts.
Now, I came to you through a kind of roundabout method. We often talk, and people are always asking me, even as adults, I want to learn how to code. What's the best way? Actually, usually they don't say that. They say, what language should I learn? And a lot of times, you know, and it used to be for a long time it was Visual Basic, and now it's, you know, the trends, the fads change. Now it's Ruby, or maybe Ruby on Rails, or, you know, maybe, I don't know, Haskell or Erlang. I don't know. It's always changing. It's a moving target. But I think what I try to tell people is you know, it's one thing if you want to learn, like get a job, that's one thing. You should learn probably Java or JavaScript, something that's going to give you a great head start in the professional world, or .NET certainly. But there's another reason to learn how to code. The reason I love coding, it's fun. It's great to be able to create something that, you know, helps you yourself. And it also gives you a great and deep understanding of how computers work. There's an even more important reason, and I learned that. So what I did is I started to point people to a program that was developed. It's printed, a book printed by the MIT Press, developed for teaching at Rice, called How to Design Programs, an Introduction to Programming and Computing by Matthias Falesin. I think that's how, I don't know how you pronounce his name, but sorry, Matthias. And I was talking about this on the air, and one of his co-authors, Sriram Krishnamurthy, wrote to me, emailed me, and said, you know, you've got some of the details wrong. I was saying Duke, not Rice. You know, four-letter college. I don't know. And he said, and then I said, well, please, let's go on, because I've been telling people about this book for years. You see, it says September 2003 version, but Matthias is doing a second edition, which is more up to date. It hasn't even come out in print yet. And by the way, I would recommend the second edition because there's some significant differences. But the point, what inspired me, and I, by the way, have worked my way through this book. I love it. It is a great way to learn coding the right way. And what inspired me is this kind of notion that maybe people aren't learning coding from the right direction. So I said, Sriram, come on and let's talk about this. And he said, no, You don't want to talk to me. You want to talk to Emmanuel. So thank you, Shriram, for introducing me to Emmanuel, and welcome Emmanuel to Triangulation. What's wrong?
It's great to be here, and thanks to Shriram for throwing me into the hot seat here.
What's wrong with how we teach programming today?
You know, there's a couple of things that I think are missing. I mean, for one thing, I think that there's a lot of great work being done in a lot of angles as far as teaching programming. But I think that there are two, maybe three very specific flaws that are hard to address. I think the first one is a lot of times in the programming world, we think that we're teaching kids problem solving just because we give them problems to solve. And we have this idea that, well, I gave my kids this problem and they solved it, so they must have learned something about what it means to solve problems. And that's not entirely true. And it's actually not backed up by any research, right? Finishing a puzzle doesn't mean you got better at solving puzzles. If you do it enough, maybe there's something magic that will happen and the kids will sort of figure it out. But there's very little attention being paid to what does it mean to explicitly teach this thing, right? We don't just give kids tons of math problems and hope that they'll figure math out. We teach them some math and then give them problems to try to practice getting good at solving them. So there's this missing piece of what does it mean to write software, to solve problems using programming. So that's one thing, and I think that's personally why I fell in love with how to design programs. I think the second challenge is that we're emphasizing coding more than programming. So let me explain what I mean by the difference there. I think coding, as a former programmer, coding is the last step in programming, right? I've thought through all I've thought through the problem, I've come up with some test cases, and then finally, the last thing I do is I sit down at the computer and I type in stuff that the computer will understand. But when you focus so much on typing in the stuff, right? Like there's all this effort right now paid to making it as easy as possible to get kids to write instructions on a computer. You miss out on all the stuff that programming actually helps you learn. I mean, when I was a CS major, I remember we would draw diagrams on a whiteboard. We'd sketch things out. We'd talk it through. There was a whole discipline to programming, and coding was just sort of the last step, in the same way that, you know, putting together a building is maybe the last step to a huge discipline of architecture. So I think emphasizing the programming approach as opposed to just making it easy to code is probably the second challenge for teaching computer science right now. And I think that the third one really has to do with this issue of transfer, which is if you're preaching to the choir, if we say, look, we want kids to learn how to program or we don't want them to learn how to code, great, the choir will believe you. But they already believed you. And so as long as you keep doing that, telling people that coding is good because coding is good,
right,
you're just going to get the same people coding. Right? What's missing is the transfer argument that says you should learn to program because it will also teach you stuff that will help you in all these other fields.
And that's key.
And that argument, yeah, exactly. That argument really hasn't been made well, and it hasn't been backed up by data. So I think that's what the issues are that we're facing right now.
Even President Obama said his daughters should have learned to code. He wishes he had learned to code. There's the hour of code. There is this great momentum towards coding, but I kind of wish people had stepped back and really thought about the curricula before they launched into this. You can go to Code Academy, and it's great, and you can learn Ruby there or JavaScript. There's lots of ways to learn, but there's not a lot of attention paid towards pedagogy, teaching, but also what's the right way to think about it. And I feel like we're going to create, to paraphrase Truman Capote, that's not coding, that's typing. We're going to create a bunch of spaghetti coders, which is how I learned, frankly. I learned basic, self-taught, and I had to unlearn a lot of really bad habits. One of the things I like about HTDP is, in fact, if you read nothing else, go to htdp.org and read the preface to the second edition. Matthias makes a really good argument that coding is, what we're doing here is not just teaching somebody how to be a computer programmer. We're teaching them how to think. And you know, in school, people always say, why am I learning math? Because it teaches you a way of reasoning, a way of thinking, a way of logic that's useful all across the board. And I think to some degree, coding can, maybe not take the place, but coding can sit side by side with the math curriculum as a way of teaching people how to think, whether or not you're going to be a computer programmer. Am I off base?
No, I think you've got it spot on. It's a discipline. It's a way of thinking. And if we value that separately from the typing part of the discipline, then we got to think about what it means to teach that. Otherwise, we're just teaching kids better ways to type.
Yeah. We don't need, they should learn that. I'm not saying they shouldn't learn that.
Yeah.
But, so I think a lot of times, you know, I've gotten resistance from educators saying, no, but you know, we're going to teach them, what is this language, racket? Shouldn't they be learning something useful? I think they missed the point a little bit. And what has happened is teaching coding has really become code for teaching somebody how to get a job in computer science. And that's really, it's much more important than that.
That's right. Yeah, I mean, we've got this middle ground. We've gotten really good at getting young kids excited. We've got some fantastic tools that get kids excited. And then at the opposite end of the pipeline, we've got these companies that say, hey, the flavor of the month right now is Ruby, or it's Python, or it's Java. And teachers are stuck in the middle because the question is not how do we get kids jobs at Google? The question is, what's the bridge between the two? How do we take those kids who are engaged and build up the fundamentals for perhaps someday getting that job, or perhaps for something else, right? If everything was about getting a job, there's a lot of stuff we wouldn't teach in high schools or middle schools.
We're talking with Emmanuel Schanzer. We're going to talk some more about Bootstrap, which is the curriculum. If you're a teacher or you know teachers, you'll definitely want to stay tuned for this, because I really think this is the way that this should be taught and it's high school, but it's also middle school. In fact, maybe even better to start younger. I'd love to talk about, you call them the Tinker Toy techniques, like MIT's App Inventor, originally from Google. We could also talk about programming tools like Tinker. We've talked about this before. It's an iPad app that teaches Tinker Toy programming. And I'm very excited about this, so hang on, because we're going to get more with Emmanuel in just a second. But first, I got to tell you about Smart Things. Everybody wants to do home automation. But you know, if you're like me, you said, oh, good, and you launched into it, and then you realize nothing talks to anything else. I have Hue lights, I have Sonos, you got the Schlage Bluetooth lock, you've got garage door, and it's like, so Smart Things was started as a Kickstarter project to create this. This is the Smart Things Hub, and the idea is you use your smartphone, iOS or Android, to talk to the Smart Things Hub, and the hub is like the Rosetta Stone. It handles all the different protocols. It talks to so many things, and suddenly your whole home is easily automated. Smart Things is such a great solution. I want you to visit smartthings.com/twit to see some of the things you can do. For instance, turn your lights on and off from your phone, or have your music play when you enter the house. You literally could have the Sonos speakers play something relaxing when you get home from work. Security alerts. You know, my brother-in-law he's got cameras set up, and every time somebody drives into his driveway, he gets an email message. Unexpected movement or entry in your home, set a camera, take a series of photos, alert you. There's energy savings too. You can restrict electricity flow to electronics or appliances after a set period of time, literally turn them off. Want to protect yourself from water damage? There is literally a moisture detector. They have all these doohickeys that are so cool. So you've got the Smart Thing Hub, you've got the Smart Thing doohickeys, and then the things that Smart Things talk to, like DropCam, Schlage locks, Honeywell thermostats, Nest thermostats, everything. iOS, I said iOS and Android and Windows Phone too. That's so nice. They're not leaving us Windows Phone users out. It's an open platform. It will work with anything you want it to work with, pretty much. And it's so revolutionary. It won CES 2015 Editor's Choice Award, and we've got 10% off right now on a Smart Thing security or solution kit. Go visit smartthings.com/twit. Browse around, figure out which solution you'd like to start with no required monthly fees, and kits starting at just $189. This is an affordable way to begin on your home automation journey, your smart home. And I got to tell you, it is so cool, so fun. And just for our audience, we're going to give you a chance to save 10% on any home security or solution kit, plus free shipping in the U.S. at smartthings.com/twit. Please use the offer code TWIT when you check out for that deal. smartthings.com/twit. Such a good idea. We are talking to Emmanuel Schanzer. He is the creator of Bootstrap, which is a curriculum for middle and high schoolers on learning to code. Now, it says you've been doing this since 2006. This is not something brand new.
Yeah, we've been at this now for approaching 10 years.
Wow. Tell me how it came about. How did you begin this process?
Sure. So, you know, when I left the private sector, I had this dream that I would be a computer science teacher. And so I moved to Boston. And like any, mature 20-something, I assumed that I would, the seas would part and I would just magically be welcomed as a computer science teacher. And so I went, to a couple of schools and said, I want to be your computer science teacher. And they said, oh, great, we could really use a math teacher. And I was sort of taken aback. I said, well, don't you guys care about programming? I mean, this is important. And they said, of course we care about programming, but, our kids are failing math. Our school needs to make a certain amount of progress every year. We got to make AYP. And so that was sort of a wake-up call to me. And the first school that took me said, we'd like to have you start out as a math coach. And I wound up taking over an Algebra 1 class. And what I noticed was that my students were really struggling with algebra, like really struggling. And even the students who got A's on the tests, I noticed that if I switched up the problem even a little bit, suddenly they would get it wrong, right? So instead of a problem about things falling off towers, if I instead give them a problem with things falling down holes, they would say, oh, this is a totally different problem. So I started thinking about when I had really learned algebra, when that concept got concretized for me. And I thought back to the fact that when I was in high school, I was one of those kids. I just memorized how to solve different types of problems. And it didn't really click for me until I got to college, when I took a very unusual kind of programming, at least at the time. There was a programming class that used functional programming. And this was a programming language that behaved exactly like math. So I started thinking about how I might adapt some of the college-level functional programming material for use with my freshman and sophomore underclassmen in high school. So originally I just wrote this as a curriculum for my own class. I was fortunate enough to be linked up with Matthias Feleisen. We actually met randomly on a train. And then years later, I've discovered that Northeastern University had this summer camp run by a bunch of students that was teaching functional programming to kids. So serendipity struck, and I was able to get a part-time job in developing and enhancing this curriculum for the summer camp. And it worked great. I mean, I had never seen kids take to this stuff the way these kids had. And these aren't, the highest achieving kids necessarily. They're your average Boston public school student. So I felt like there was something really, really important here. And I switched gears and became a middle school academic coach because that gave me more opportunities to experiment with the curriculum. And over the years, gradually other teachers, but also engineers or undergrad computer science majors, started asking if they could use the curriculum as well. And over time, the curriculum has grown and been refined. In 2007, I linked up with Sriram Krishnamurthy and Kathy Fissler, professors at Brown and Worcester Polytech. And at that point, Bootstrap really took off and matured into sort of a finished product. So, we've got a nice booklet here for teachers, all the lesson materials, accompanying student material for kids. And now it's evolved into something that can be integrated into a mainstream algebra class or developed as a computer science elective, as a standalone class for schools.
I think that's interesting. So it's easy for a school to integrate because it fits their math program. They don't have to say, oh, we're going to teach something in computer science. It's algebra. Let me ask you, though, you said a phrase, and it's I think important to describe this. What is a functional language?
Yeah, so a functional programming language means a programming language that sort of behaves the way that algebra or math behaves. So functional languages are very declarative, meaning that you write code that you sort of declare what the code should do, and you don't need to think at the same time as what the machine should be doing to execute the code.
So what languages are functional? What languages are Lisp or Scheme? You said
Lisp, Scheme, OCaml, Haskell, Racket, Pirate. There's a whole bunch of functional programming languages out there.
I know every time I say Lisp, people go, "Oh no, I don't want to type parentheses."
Yes, functional programming languages don't all have parentheses.
Okay.
They're really good for some stuff, but yes, when I say functional programming, I don't mean you have to have parentheses. Okay. In fact, one of the languages we use doesn't have parentheses.
So I've been a big fan. It's cool that you met Matthias because I've been a big fan of his book, as I mentioned, HTDP, How to Design Programs. And what I love is MIT has put that book online. It's free. It uses a functional programming language called Racket, and you can download Dr. Racket. And what's cool about that is it not only is it a full-blown language that you could actually write full programs in, but it has modules or teaching packs that allow you to dumb it down. Start at kind of a simple level and then add features so that one of the things that happens when kids start to learn to program, or anybody, is you get weird error messages. And you know, what does that mean? So it looks more, it's more sensible. It's designed to teach.
Yeah, that's right. And that's sort of the part that I'm talking about as far as this emphasis on what does it mean to teach programming, not just getting kids to code. And Matthias and the PLT group really pioneered this with Dr. Racket, that depending on the language level you're in, sometimes for a beginner, you want a constrained language, because the more constrained it is, the more helpful error messages you can give, because there's only so many things that they could have intended to do. So if they do it wrong, you can give them helpful feedback.
I actually love Dr. Racket, and I install it on all my computers because it's a fun thing to play with. You have a REPL loop, read, evaluate, parse, read, evaluate, what is it? And then loop back. Read, evaluate.
Right, the read, eval, print loop.
Print loop. And so, and another way to talk about that would be like, it's like an interpreter. So you can type in commands. Yeah. And I think for teaching, it's one of the reasons I also love Python. And for teaching, it is very natural to be able to, as you're starting to learn to program, try stuff, and it'll give you a result right away. You just type in, 2 + 2, and it'll give you a result. Now, there's one weird thing about Racket. It's a postfix, not infix.
Prefix. Yeah.
A prefix, not infix. So does that confuse people? So it's not 2 + 2, it's plus funny. 2, 2.
That's right. So anybody who learned to program on an HP calculator is really familiar with putting the function first.
Yeah.
Yep. And it's funny because the people who learned on the HP calculators, they often are so addicted to it that they'll switch to something else after you pry it from their cold, dead hands.
It's really true.
There's a very intuitive way of thinking about arithmetic operations where you put the function first. And this is no different than the way we do every other function, right? I mean, imagine if you're trying to program something in JavaScript, Python, pick your favorite language. If you've got a function that loads an image and another function that maybe rotates that image and another function that stretches that image out, if you want to do all three at once, you wrap one function inside the other. You don't put them in between each other. So this idea of infix notation is actually very weird. You don't see it in any other programming language. You don't see it in any other branch of mathematics. And yet, for all these languages that use infix, they keep this strange sort of bastardized thing where the plus goes in the middle. So Racket breaks with this. Racket says the function goes in the beginning, just like every other function you use. And it's funny. We don't see a lot of people getting confused by necessarily that as much as they need to know why, right? It's not like they can't figure out that the plus comes first. Right. They want to know why it comes first. And
once you explain it,
there's actually some really interesting history here about the way we teach math and why people expect plus to come in the middle, but everything else not to.
Yeah. This is the Dr. Racket page, which I'm going to point people to if they want to download it, racket-lang.org. And they do, at the bottom of the page, recommend how to design programs. Realm of Racket's a lot of fun, also a great way to teach kids. But if you're going to do a curriculum, I think it's a really appropriate place to start is bootstrapworld.org. And you use, which is and I'm thrilled to find this, Dr. Racket-like browser-based programming tool called WeScheme.
Yep, that's right. So if you have a web browser and internet connection, you already have our software installed. There's nothing to download, nothing to install. All the files live in the cloud. It's really handy as a teacher. So
this is where you enter a program. I'm going to go down below. Let me do this to show the little interpreter here, and I can do. This is the notation plus 2. Whoops, did I do that right? Plus. Oh, I've got shift on. Plus 2.
You can grab that gray bar and drag it up if you like as well.
Oh, good. Make it a little bit bigger here, and this is all in the browser. That's cool. So you. Oh, it didn't do it. Did I do something wrong?
Yeah. Well, so. Racket is one of those languages where you need parentheses.
Yep. You learn this very quickly, and that's one of the great things about having an interpreter. You go, oh, and then you see it's balanced to, 4, good. Very nice. Now, this error message is an example of an error message that might confuse. Is there a way to, how do you handle that for the kids?
So that's actually not an error message. So what you typed in on that first line there was 3 different programs. The first one was the program plus,
right.
which is a function.
Right.
In fact, try it now. Just type in plus by itself.
Okay. There you go.
And there
I
you
get
go.
the same thing.
It's telling you plus is a function whose name is plus.
So I've actually queried the interpreter to say, what is plus? And it's telling me. Just as if I wrote, quote, hello world, end quote, and it would repeat it back. Oh, that's a string called hello world.
That's right. So in this language, and in all functional programming languages, functions are values, and you can pass them around just like you would the number 2 or 3 or the string hello world. So 2 is a value, and if you type in 2, it prints out 2.
Right.
Hello world is a value. You type in hello world, it prints out hello world. Plus is also a value.
Got it.
When you have functions that can be treated as values, you can do really cool stuff. That's how higher order functions work. You can pass functions around to each other.
So how do you incorporate this into a math curriculum? Do you tell me about that? Tell me about that.
Sure. So in a math curriculum, right, the focus is very much around using different components of algebra to build something students care about.
Mm-hmm.
So I'll give you a quick example. In Bootstrap, the final product is that kids build a simple video game of their own design. And the first step in doing this is that kids want to import images, bring them into their program, and have them show up on the screen. So we teach them, simple coordinate systems and so on, which they then use to position all the characters on the screen. So you might have your leprechaun up here and maybe a shark over here. And the kids can say, okay, that's my game. I see what it's going to look like, but nothing's moving just yet. And so then from there we say, well, what does it mean for a character to move? And they say, well, I already learned coordinates, so I know how to put a character here, but I want this character to move a little bit, side to side. And so that gives us a model for introducing the importance of functions. So instead of saying this character's position is the number 10, we might say this position is defined with respect to time. And so they write a linear function that makes their character fly across the screen, and it goes off the edge and never comes back. And the kid says, all right, it's cool that it moved, but it's supposed to come back. How do I make it come back?
Yeah.
And we ask them again, well, when should it come back? What do you mean by that? And they say, well, when it's off the edge of the screen, right? When it's off this edge, I know it should come back. Okay, so what is the x-coordinate when it's off the screen? Oh, it's less than 0. So we introduce inequalities in the plane, right? And so we introduce Boolean inequalities, and or, union and intersection. And so kids are learning the math to bring things back on the screen. Responding to key events, moving up and down. If I hit the up or down key, that's a piecewise function. Collision detection, when 2 things blow up, well, you only know how far apart they are if you know the distance formula. That's the Pythagorean theorem. So each piece of the video game comes from a part of algebra that they need to know. And when they're using that, they're programming this stuff in using a programming language that behaves exactly the way the math does in their textbook. So there's no assignment, there's no for loops. Every construct they're using can be found right in their regular math book, as opposed to teaching them something that's totally different and weird and behaves nothing like math. We're teaching them the math itself. So that has a benefit for students because they see the transfer. And this also has a benefit for math teachers, because math teachers don't need to learn 50 new constructs that don't exist in math. They can do it using only what they already know as math teachers.
That's really cool, because you're right. Kids, if they're doing it, the first thing they say is, okay, I want to write a game. So immediately you grab their interest. And I bet you, the problem with math for me always was it's very abstract. And so I know certainly when you learn physics, having some experiential things to go along with the rules you're learning, it makes Newtonian physics really easy to learn, because you push something and it goes. And having this, it's great. It makes math experiential. They're actually experiencing what happens.
That's right. And in fact, there's actually, so everyone sort of knows about SIGP, right? The structure and interpretation of computer programming, for the famous MIT
Abelson.
Book. There's another book that Sussman and Abelson wrote that teaches mechanics through programming.
Oh, that's great.
Right, and it's the same concept. It's directly applying programming to make the math of physics real. And so that's exactly what we're doing here as far as algebra goes. We're making algebra real by having kids program something that they care about.
You've been doing this almost for 10 years. Do you have any results, any studies that show how effective it is?
We do, and we're actually really excited about this. So the phenomenon that you're asking about is called transfer, which literally means by doing something in domain A, do kids automatically get better at this other domain B as long as the domains are related? And it's been really hard to prove transfer between programming and algebra. A lot of folks have tried in the past. What we've done in the last year is we've been giving out these pre and post tests to students in 6 schools across the country. Middle and high schools, 8th and 9th grade algebra and computer science. And the pre and post tests have no programming on them whatsoever. Every single problem on the test is a straight up pencil and paper algebra problem, many of which are actually borrowed from the Massachusetts MCAS. So same kind of math problems kids are going to see on a test. And what we found is a statistically significant improvement across the board from students on these tests. So we do see evidence of transfer of kids getting better at algebra by doing this computer programming. So if you're a principal or a superintendent, maybe you don't have room for computer science, but chances are you've got room to help kids in math. And so for us, that's the main argument, right? Programming is great. We think you should do it. But if you're not already sold, how about helping students with algebra?
Absolutely. In fact, it says on the bootstrapworld.org site that you are aligned with a Common Core for algebra.
That's right. So, you know, Common Core is pushing algebra into 8th grade as opposed to primarily a high school class like it used to be. But it's not just Common Core, right? So in Texas, the standards are also moving algebra down into the middle school range. So, you know, Common Core is sort of a useful signpost for us. But even if you're not in a Common Core state, the trend is teaching algebra earlier. And if that's your concern, we've got a great way to learn it.
Kids seem to really enjoy the experiential nature of writing code. And to think about writing a game, I mean, that inspires a kid. That's the kind of thing they go, hey, I would like to do that.
Absolutely. I mean, that's how it's visceral, right? When someone thinks about, oh, that time they finally understood derivatives or integrals, for a lot of people, that moment is physics, right? They were using the math to do something that really mattered, and all of a sudden, they remember that forever. And that's the same thing we want to provide for algebra, that it's visceral and important. And they might not remember like what the Pythagorean theorem is called, but they sure as heck remember that if you want to see how close two things are, you use that formula to make stuff blow up in your video game or to do something else in real life.
A lot of kids are learning early about coding from things. We mentioned Tinker, which Mike Elgin's son, our news director's son, is an employee of Tinker, and we've talked about that a lot and recommended it for iPad and other ways. You call it kind of Tinker Toy. You know, Abelson also is involved with the MIT App Inventor program, which is very similar. It allows you to design an interface on the screen, and then once you've designed the interface, to attach little blocks of code. How does this... Is this I know you're not going to say it's misguided. I mean, after all, it is Abelson. But how does this translate now into what you might be doing later?
Right. So when I use the term Tinker Toy language, I mean that not in any sort of disparaging sense.
No,
right?
it's just like you plug and play. It's so cool. You plug it in and it goes click and things work, and it's a great experience for people learning how to program.
That's right. I mean, so we've gotten really good at the sort of Lego block style of programming,
right?
Because that's a really valuable way to get people started, especially to get young students started. There's sort of, you know, there's instant feedback. There's a quick win. You can very quickly make something move around the screen. You're not worrying about syntax all that much. These block languages make it really easy to play, and play is valuable. I think. In particular, given the MIT heritage, we know how important play is for the learning process.
Right.
But I think the challenge is there's this midpoint between getting into something through play and then mastering it as a professional. You know, in art, for example, finger painting is great, right? It gives you a chance to play, to experiment, to build. It's low risk. But at some point, if you want to be a professional artist, there's this like middle ground where you learn all these techniques and you're learning the fundamentals. So maybe that's perspective, maybe that's shading, maybe that's studying art history somewhat. Finger painting alone isn't going to get you there. And we all understand that. The same is true for math, right? There's lots of ways to play with math early on just to get a feel for things or a sense for things. if you want to be a mathematician, at some point you need to learn the fundamentals. So I think that I think there's been some amazing work that's been done, and I think we'd be remiss if we didn't mention Dan Garcia and his great work at Berkeley with Snap, with these languages that are phenomenally good at getting kids excited and allowing them to play. I think what's sort of the new frontier right now is how do we transition them? How do we start to build up these fundamentals for people, for students, so that they're ready to go on, whether it's going on to calculus or physics or something else that's not necessarily a hardcore programming job, although it often does use programming, or to get them ready to move on to the hardcore actual computer science major. How do we bridge that? And so I would say that Bootstrap is a phenomenal way of taking students who are already engaged using these great tools and saying, all right, now you've had a chance to play. Now it's time to start thinking about the fundamentals of what it really means to decompose problems, to solve problems, and to write software. There's an awful lot more to it than what you've been doing maybe as experimenting with blocks. So we're going to start gently introducing you to what that more really means.
We're talking to Emmanuel Schanzer. He is the creator of Bootstrap. Find it at bootstrapworld.org. We're going to have more in just a moment. First, though, a word from Personal Capital. Let's talk a little bit about money. Remember Bill Harris on Triangulation a few weeks ago, the creator of Personal Capital. He founded PayPal with Elon Musk. He was CEO at Intuit, learned a lot about finance, but realized there was a big gap, and I have to agree, there is a big gap, especially for us baby boomers, but even young people, between putting money aside, putting it in savings, knowing we have to plan for the future, plan for a rainy day, plan for retirement, and how we manage that. And there's often two paths people go down. One is you hire a broker, and the broker tells you what to do. But the thing you have to remember is the broker is essentially a salesperson paid on commission. The more you trade, the more the broker makes. Or you're like me, we're technology sophisticates, do-it-yourself types. You kind of say, I'm going to, open an account at a brokerage, and I'm going to handle my money. Both systems can kind of break down. I've got a solution for you that's free, that's easy to use, that will really help you make the right choices, whether you want to have an account, a brokerage account, and have some advice from somebody, or you want to do it yourself. It's called Personal Capital. It's free to start at personalcapital.com/triangulation, and right away you get the first immediate benefit, the Personal Capital dashboard. You get all your accounts in there, and by the way, this is totally secure and private. You don't have to worry about that. You get all your accounts in there. Just take a few minutes to set up. Now you have a dashboard, a real-time dashboard on your computer, your tablet, your phone, even your Android Wear watch that lets you know what's going on with your money. If you're paying too much in fees, if you've rebalanced your investments, if your investment goals are being met, it helps you plan for the future in budgeting. This is all free and really easy to use. And the problem, we got all this stuff in different accounts and different websites and different passwords, and it's hard to see everything all at once. So this really solves that. Then Personal Capital takes the next step with financial advice. Now, you don't have to take advantage of this, but once you put more than $100,000 in assets in their dashboard, you can get a free 30-minute review, not from a broker, but from an independent, not paid on commission financial advisor. You can discuss your financial goals, your risk tolerance, that's very important, the time horizon for retirement. All of this is free. It's a new offer, and all you have to do is track more than $100,000 worth of accounts on your dashboard. 30-minute free review. The final step, and it's completely optional if you wish, you can also open an account with Personal Capital, put money in, and use the tools, you use the advisors if you wish, to direct your investments. I got to tell you how important this is. If you're thinking that Social Security is going to take care of you in your old age, get a clue. It isn't. You need to plan. You need to see where your money's going, and you really don't want to lose years off your retirement because of high fees. Personal Capital will help you all of that. Free. No obligation. Personalcapital.com/triangulation. And if you link on more than $100,000 in assets on your dashboard, you can do that free 30-minute portfolio consultation, which I highly recommend. It's low pressure, no obligation. It's free. Personalcapital.com/triangulation. Try it today. We're talking to Emmanuel Schanzer, who is the creator of Bootstrap, bootstrapworld.org. I talk a lot about, we always get questions, how do I get my kid into technology, into programming? people who themselves would like to learn. I've mentioned before How to Design Programs, that great book by Matthias Felesen, and we've talked a lot about Dr. Racket, the tools that you can use. Bootstrap is all about that for middle schoolers or high schoolers, and it can be integrated right into an algebra curriculum, so you don't even have to have a computer science curriculum, and yet you're getting kids comfortable with programming, with thinking in a kind of a organized way, with problem solving. And you're also teaching them, I think this is important, skills that will be useful for them if they do become professional computer programmers or computer scientists. Everything in here it's test driven, right? Design. I mean, you're learning how to design programs, literally.
Yeah, so what we do is called example-driven development, which is a little bit different than test-driven development, but any math teacher will recognize it. So your average math teacher, whenever they have their students solve a problem, the first thing they do is walk through a couple of concrete examples to make sure that a student can reason about this problem in a specific sense. So if it's a word problem about, a train moving 80 miles an hour, rather than saying, all right, kid, go and solve the general sense, first they want to walk through, well, how far has the train gone after 1 hour, 2 hours, 3 hours? And by scoping out these examples, students then start to see a pattern, and then they can derive the general solution. So this is something that every math teacher already does. It's totally common in a math classroom. And so we're applying that to the programming domain. So it's very similar to test-driven development. Basically, we say, if you can't think of how to test your code or how it would work for even one example,
love that.
You don't have business writing the code at all. So by starting with that, kids develop a really firm sense of how to write their code.
And it's a great, the number one thing I hear people complain about in math is word problems. I can't solve that. So it gives you tools for breaking it down and actually solving it. And I don't think I learned those in school, That's that transference you're talking about, where I learned how to do it by rote more than anything else.
Yep. That's right. I mean, algebra, ironically enough, it's got this bad reputation as the time math gets scary.
Right.
But algebra is actually the time math gets creative and cool.
It gets cool. It goes beyond
what
arithmetic.
Is programming other than solving word problems all day long?
Right. I love it. How much is it, if a school wants to do this, do you charge for the curriculum? How does this work?
So if you've got a motivated teacher and a lab full of computers and web browsers, you don't need to pay anything at all. The curriculum is freely available on our website, bootstrapworld.org. The software is freely available as well. Everything is free. The student workbooks that I was holding up earlier, you can buy them from a publisher. I think they're about $8 a kid. But the PDF for that exact same workbook is also available on the website for free. So, if you're an individual school, you can jump right in. If you want professional development, we offer really high quality workshops for math and computer science teachers. We've actually got a big one coming up in Philadelphia this August. It's open to any teacher from any district, August 5th, 6th, and 7th. It's a 3-day workshop held at the University of Pennsylvania's School of Engineering, so we're grateful to them for hosting us. And any teacher or adult who wants to get invested and check out what this thing looks like can come and get trained. Finally, we also partner directly with school districts. So we work with school districts who will sign up with us to train a large number of their algebra or computer science teachers, and we'll work with them over a period of years to develop their own in-house Bootstrap training team so that they can be totally self-sufficient.
And might mention that workshop in Philadelphia in August is a $150 registration fee. It's really affordable, and that includes all the materials, and you get 21 hours of professional development. That is a great price. And again, it's all free. And what I really like, I think a lot of schools have iPads or Android tablets, or they have Chromebooks, and they can't install software. You've made this, with WeScheme, you've made this possible even in a browser to do this whole curriculum for free. And I think that's such a gift.
That's right.
Thank you.
Yeah, well, I think this gets to a really important issue that's often not really discussed, which is equity, right? So if you're in a school district where you've got an IT professional in your school who can do installation and provisioning for you, that's great. But so many schools, especially the schools who need it the most, don't have the ability to install software. So if you want to use Bootstrap with this Racket language, bam, WeScheme is right in the browser.
So great.
We also have an advanced curriculum that allows you to use another language called Pirate. It looks a lot like Python. That runs in the browser. So in terms of technical equity, we want to make sure that any kid can learn to program. And by targeting Algebra 1, we're making sure that it's every kid, right? Not just the kids who opt into the programming class, but it doesn't matter, you know, what color skin you have. It doesn't matter if you're rich or poor. It doesn't matter if you're a boy or a girl. Everybody takes Algebra 1. So if you want to get programming to really be available for everyone, you got to get into the mainstream classes with a software tool that runs in the cloud. So that's what we're all about, and that's where we put in our work.
So great. I noticed that you have partnered with code.org. That is those are the Hour of Code folks. Gosh, you know, I want to like push people in this direction instead of saying, oh, just go to Code Academy and learn JavaScript. It's just, this is the right way to learn. It's so easy to integrate it into your existing curriculum without a computer science curriculum. It's free. And so many teachers end up don't get the professional development support they deserve. They don't get they're using their own time and money often to teach this kind of stuff. This is a great solution for them, for Algebra 1 teachers, for computer science teachers. What about, and you don't address this specifically, but I'm just curious. I know there are a lot of people watching who are adults, people like me, who would still like to learn to code. And I would encourage them to kind of learn right. You can then learn Ruby on Rails or, you know, JavaScript or .NET. Where would you go if you were an adult wanting to do this?
Well, I mean, there's a lot of resources out there. I mean, obviously, if I'm putting on my self-promotional hat, I would say, come join us in Philadelphia.
Yeah.
$150. Spend 3 days and learn this stuff, right? This is open to anybody right now. So if you want to, you know, have a really high-quality PD where you learn what it is to code and what it means to teach someone else, that's a great opportunity. All of our materials you can also work through on your own. You don't need to be a classroom teacher. You can just check it out. It's a gentler introduction than what HTDP does, what How to Design Program does, because it's targeted at a younger audience. So, I mean, I would say, honestly, that's where we start.
I would start there, and then you can go to HTDP or Realm of Racket and work your way up to Ableson, SICP. And if you work through all of that, I think you'd be pretty well equipped to get into the world of computer programming, frankly.
That's right. Yeah, I mean, that's what's so awesome about this. That kids who start in Bootstrap 1, who might be, let's say, in 7th grade, in some cases even younger, when they finish Bootstrap 1 and move on to Bootstrap 2, by the time they're done, they're already on Chapter 7 of the How to Design Programs textbook.
That's awesome.
They can jump right into a college-level course.
Wow.
And they know the first couple of weeks of material cold. And that scales all the way up through upper-level computer science classes at the university level or in professional contexts. And this pipeline is smooth, and you build in what you know without having to switch languages, without having to switch tools. It's a really nice migration pathway, and that's something that we don't really see anywhere else.
The other thing I would say is there are a lot of people here who are computer professionals, computer programmers or engineers, and this makes me, and I kind of have the same attitude, Emmanuel. When I retire, I want to teach this stuff. I would love to volunteer in a classroom and teach this maybe after school or as an extracurricular, because it's fun. And getting kids excited about this is so fun and so satisfying. You have actually a testimonial from Bill Stitson, who works at TripAdvisor, he's a software engineer there, about working with kids and teaching them. He says he has a Nyan cat, and he says, where should you move it? A little to the left, a little to the right. And so then he has a number line, and then he works his way up to, he says, the kid invented the x-axis on his own. And what a great feeling. What a great feeling to do this and to volunteer. And I think this would be a great place to start. Bootstrapworld.org. A few more words with Emmanuel Schanzer in just a second as we continue with this inspirational episode of Triangulation. You know, they always say guys don't like to shop. Oh, yeah, we like to shop for tools, for gear. Well, what we don't like, at least what I don't like to shop for, is clothes. I don't want to go shop for clothes. And as a result, many of us, let's face it, spend a lot of time in jeans and T-shirts. But if you'd like to upgrade your look a little bit, I've got a great solution I've found that just transform. First of all, you don't go shop. The shop comes to you. It's Trunk Club at trunkclub.com/twit. You want to look your best. Don't rely on your own eye, your wife's eye. You can do this. It's so much fun to do it. With Trunk Club, you get your own personal stylist. Mine is Robin. I talked to her for about half an hour, told her a little bit about me. I said, look, I'm not a hipster. I'm a little heavy set. She put together a list on the web of stuff. I said, kind of like hot or not. Yeah, I like that. No, I don't like that. Then she put together a trunk. Great stuff, and it's so well, laid out. And you just shirts, sweaters, shoes. I'm wearing actually some of the Trunk Club stuff. I got this is a sweater that was in the Trunk Club that I love, a V-neck sweater, because I told her I want a lot of sweaters. I just love it. Then, and this is the coolest thing, you've paid nothing up to this point. You pick out what you want and you ship the trunk back. Postage to and from, free. Everything's free. In fact, you only pay when you send the trunk back, and then they see what you kept and you pay then. There's no minimum purchase, and best of all, there's no subscription. I'm not going to get another trunk next month. I'll get another trunk when I ask for it. Once your trunk arrives, you have 10 days to try things on at home. You keep what you like and you return the rest free of charge. This solves so many problems. I could try it on in the comfort of my own home. Everything fits because she has my sizes. She also has my style, so there's nothing, I'm not going to get no kilts, okay? I don't want kilts. She knows that. She didn't send me any kilts. I'm not sure she ever would have thought of that, but anyway, I love you, Robin. You're the greatest. And now, every once in a while, I say, it's time for me to kind of get a little bit more stuff, and I'll click the button, and I'll get another trunk from Trunk Club. You're busy like me. Maybe you don't like to shop like me. I want you to make it easy. Rely on your own personal stylist and let Trunk Club do the work. There really is no reason not to. Great clothes, handpicked for your style, at no cost to you. You only pay for what you keep. And there's no subscription. I want to emphasize that, because sometimes you sign up for something and you go, are they going to send me clothes every month? No. Whenever you ask for it. Sign up with Trunk Club now to get started. Go to trunkclub.com/twit. Meet your stylist. You can't have Robin. She's mine. And get your first trunk of fabulous clothes shipped for free. trunkclub.com/twit. This is such a brilliant idea. I've been looking for this my whole life. Now Lisa's mad. My wife's mad because she said, well, I want to do, nope, just for guys. Sorry, Lisa. trunkclub.com/twit. We're talking to Emmanuel Schanzer, Bootstrap Worldorg. This is, I think, so important, because you're not only integrating this in a painless way into existing middle school curriculums. Any school can do this, even if there's zero budget. Any teacher can do this, and math teachers, you're going to kind of get excited about, I think, about this, because it's simple. You don't have to be scared off. I don't know anything about computer. You don't need to. You know about algebra, you're set. And you're teaching it, in my opinion, you're teaching it the right way. You're teaching, the kids are learning what they need to learn in a sensible way. Not all of them are going to go on to be computer programmers, but those who do will have learned the fundamentals in a proper way. I just love this idea. How many people are using Bootstrap?
So, one of the downsides of giving everything away for free online is that it's really hard to figure out who's using it.
Yeah.
So this year, we're going to train probably 300 or 400 teachers around the country. And each of those teachers, if they're teaching a full load of students, could be 50 to 80 kids apiece. As far as how many are actively implementing it right now, I would say we're going to hit somewhere in the vicinity, maybe not quite 10,000 students this year, but close to it.
Do you get some resistance from people who say, "Oh no, it's not pre-professional," or I mean, what do people say to you that are negatives that you have to overcome?
Sure. So the big one, like you said, is someone saying, "Well, why aren't we teaching Java?" Right? Kids have to be learning Java right away, or it's sort of worthless. Ugh. And that critique has gotten a lot softer in the last couple of years. I think people have sort of looked at the number of students who are completing the AP Java test, and they're realizing that Java is a great language to learn, but maybe it's not the best educational language. So Python now is sort of the replacement, and people are saying, well, we should really be teaching Python because that's the job. And honestly, if your view of schooling is that its only purpose is to get a job, I'm not going to quibble with you, but I think that, again, if that's the threshold, there's a lot of stuff we need to get rid of in high school.
Yeah.
So I think most people sort of believe that high school is about more than just learning how to get a job. It's about preparing you to think.
Right.
And nowhere is this more obvious than in an algebra class, right? The skills that you learn in algebra are part of everything. If you want to go on to calculus, obviously you need algebra. If you want to model projectile motion in physics, you need functions. You want to balance chemical equations, you want to model population growth or rates of change in biology, you want to use abstraction in computer science, right? Everyone understands that if you care about STEM at all, as a computer scientist or as just, any scientist, if you care about STEM, algebra is the gateway class. And so by positioning ourselves and saying, look, this is going to improve kids' performance in algebra and get them to really understand this, I think by attaching ourselves to algebra, people sort of get there's more going on here than just job skills.
It's also more fun. And I think, I've always thought that the way you approach a new thing, particularly technology, is going to inform how you'll think about it for the rest of your life. I always talked about this on Tech TV, that in the early days of computers, there were kind of two classes of people. People who thought computers were fun because they started with gaming, or it was, it was something fun for them. And then people who think of computers as a tool because they learned at work, or they used a word processor or accounting software. And you're almost like baby ducks. You're imprinted with that notion of what it is. And so there's the enthusiasts, who are probably mostly people who watch our shows are enthusiasts, who found computing fun. And then there's people who say, well, it's for work. It's, it's not fun. It's just something I need to do. And they're never going to enjoy it. And I feel sorry for them, because if you come from the enjoyment, you still can do all that other stuff. You can still do spreadsheets and QuickBooks, but you also enjoy it and you love it and you have a sense of pleasure from it. And I think that's a very strong reason to teach kids not Java, not Python, not JavaScript, but to teach kids in something that makes it fun for them. It's true for math too. You can really turn people off to math. If you can turn them on to math, and if you can turn them on to coding at the same time with concrete skills and things flying across a screen, they're going to love it. And that's a good thing.
Yeah, I think you've hit the nail on the head here. I think that it's so easy to confuse teaching a subject with teaching a tool when it comes to computer science. No one says that learning chemistry should be how to use a Bunsen burner. Nobody says how to learn math is how to use a calculator. And yet so often when we talk about teaching computer science, what do we come up with? We come up with teaching Java, teaching Python, teaching Racket.
Yeah.
Right? If you think that if the title of your class is the name of the tool you're going to use, then maybe you're not thinking about what it is you're trying to teach.
Yeah.
Right? We don't need a Java class any more than we need a Racket class. Your viewers out there, I think, are all bought into the idea of teaching computer science. So the question for them is this. If you care about teaching computer science, don't ask yourself, what language am I teaching? Ask yourself, what are the things we want kids to learn? And then maybe what language is best to teach that? And then figure out, okay, how do I make that fun? Right. And it needs to be all three. Right. You got to start with the learning first. Then you pick your tool. Then you come up with something awesome to do with it. And sometimes your answer might be Java. Sometimes it might be Python, and that's fine. But you got to consider those things together. Otherwise, you're just teaching Bunsen burners or typing. And so with Bootstrap, if what you want to learn is math, we think a functional programming language is the way to go. And we've got a great curriculum to get you there.
We should mention Bootstrap is a nonprofit. You can make a donation. You've received funding from some of the biggest companies in the world, including IBM and Microsoft and Apple and NVIDIA. And I think that's great. Code.org is giving you support. I think that's great. You have after school. You mentioned after school here. It doesn't just have to be part of a curriculum.
That's right.
Somebody like me could come along and say to a school, "I'd like to do an after school program."
Yeah. In fact, we've got engineers from practically every company in Silicon Valley who've taught this in the context of after-school programs.
I love that.
So if you're somebody who wants to teach that, we partner with a number of different nonprofits that run after-school programs. We can link you up with them. And it's a great opportunity to get involved where you're doing more than just, a one-day exposure, but you're really teaching something rigorous that can scale.
Do you have any metrics on if this helps with SAT scores?
We don't have metrics on that, no.
Yeah, I imagine it does. But you're mostly starting in 7th and 8th grade.
It varies a lot. So for some states, algebra is a straight up 8th grade class, and so for them, we're the perfect place for that.
Right.
Other states, maybe algebra is a 9th grade class, and then even for the states that are doing it as an 8th grade class, we all know that there are some schools have perhaps like an advanced math or accelerated math track. We actually partner with the Anne Arundel County School District in Maryland, they've got a couple of schools where they have a gifted and talented 5th grade class that uses us as part of their accelerated math and computer science. So if any of you out there are, principals or teachers, or you know someone who is, Bootstrap's a way to introduce kids to algebra. And that could be younger kids who are ready for something advanced. That could be 8th or 9th graders in your state that are learning it right then and there. That could even be 10th or 11th graders who might have failed algebra the first couple times, and they just need to learn it in a new way.
You have a map on here of where people are teaching Bootstrap, but it makes me sad. It's U.S. and Canada. I want to see. Oh, there's some in Asia. Interesting.
Yeah. So that's one of the awesome things about giving your stuff away. You never know who's going to use it.
I love that.
We actually just got some folks who have translated Bootstrap into Finnish. Some folks who are working on translating it into Turkish, Italian, and also Brazilian Portuguese. So it's being used in more places than I or any of us really realize. But it's resonating, and a lot of people are picking this up.
Well, I want to put my personal push behind this. This is the way to do it. There are lots of ways to get kids into technology, into STEM. But it's not just about STEM. It's not just about technology. It's about learning how to think, how to reason, and feeling some sense of mastery over mathematical topics, over logical topics, and over technology. And even if you never write another program, that understanding that you get, the deep understanding that you get from doing this, is for a lifetime. And this is the way to do it. So if you're a teacher or an administrator or just a volunteer and you've been thinking about this, I really want to encourage you to look at bootstrapworld.org, and I want to thank you, Emmanuel, for creating this, because I think you're making a huge difference, and I want this to be everywhere. It's the right way to do it.
Awesome. Well, hey, it's an honor to be here and talk about this stuff with you, Leo. Thanks a lot.
Emmanuel. Thank you. Emmanuel Schanzer at bootstrapworld.org. Check it out. We do Triangulation Mondays. Normally, this one's pre-recorded, but normally we do it Mondays, 11 a.m. Pacific. That's 2 p.m. Eastern Time, 1800 UTC. We love it if you tune in, because when you're watching live, you can chat with us. You can give me questions and ideas, and I really appreciate that. But of course, all our shows are on demand, always available from our website, twit.tv/TRI. But you can get it wherever you get podcasts, like iTunes, the podcast app on your mobile device. And of course, every mobile device has a Twit app. We didn't do them. There's the great people in our community have created these for iOS, Android, Windows Phone, Roku. Please check it out. And just the key is subscribe, because you don't want to miss an episode. Triangulation is always an inspiration, always fun. You always learn, and I always love doing it. Thanks for being here. We'll see you next time on Triangulation.